Every year, millions of dollars and countless gallons of toxic chemical droplets are deployed against a single, tiny pink flower. We spray our lawns and fields to eradicate it, treating the plant like a hostile invader. But this chemical obsession comes with a hidden cost. By stripping our landscapes of this specific plant, we've inadvertently engineered a fragile agricultural system. We're left with severely compacted dirt, rapidly depleting soil nutrients, and starving, collapsing pollinator populations. The plant we are so desperate to kill is Trifolium pratense, commonly known as red clover. And the irony is that this targeted weed contains the exact biological mechanisms required to reverse the ecological collapse we're seeing in our soils today. Before the chemical era, scientific and botanical authorities classified red clover as a foundational crop. These anatomical cross-sections of the roots and florets document a level of biological complexity that was once considered essential to agricultural stability. By attempting to force nature into a pristine, artificial aesthetic, industrial farming practices dismantled the specific plant communities that historically maintained soil fertility. To see how this engine actually works, we have to look underground. In its very first year, red clover drives a massive, meter-long taproot directly into the earth. It physically shatters compacted heartpan layers, opening up channels that turn dry dirt into a porous, water-absorbing sponge. Once entrenched, the clover root releases specialized chemical signals into the surrounding dirt. This broadcast invites a symbiotic partnership with Rhizobium, a specific family of soil bacteria that colonizes the plant's roots and forms tiny, visible nodules. Inside root nodules, microscopic factories pull inert nitrogen gas from the air, converting it into bioavailable compounds. Comparing efficiency, synthetic nitrogen creates a sharp spike that rapidly washes into toxic runoff. Clover establishes a slow-release nitrogen bank, providing a stable retention curve all season. This biological cycle rebuilds soil fertility from the ground up, providing a natural alternative to synthetic chemical inputs. Above ground, the plant operates as a keystone companion crop. Its leaves form a dense, living mulch across the topsoil that physically smothers invasive weeds and locks in vital moisture for neighboring plants. And then there are the blossoms. The specific geometry of a red clover flower is perfectly tailored for long-tongued pollinators. It acts as a massive, season-long nectar reservoir, easily accessible for bumblebees successfully navigating the deep tubular florets. This nectar reservoir creates an immediate ripple effect. By establishing a reliable food source, the clover patch attracts an army of parasitic wasps and predatory insects. These tiny mercenaries set up camp and naturally hunt down crop-destroying pests. The plant functions as an automated ecological hub. It constructs a self-regulating defense and supply network that actively nourishes and protects every other plant growing in its vicinity. This localized health quickly scales up the food chain, passing directly from the soil into the large mammalian herbivores that graze on the clover. Agronomic data reveals that red clover contains unique polyphenol oxidase enzymes. In ruminant animals, these enzymes actively prevent protein from degrading in the stomach. This delivers highly concentrated bypass protein to the animal, making clover a premium livestock forage that sustained early agricultural economies. That medicinal utility extended directly to humans. Long before synthesized pharmaceuticals filled these apothecary shelves, global traditional healers and early pharmacists relied on red clover blossoms. They documented medicine in the form of a potent alterative, a blood-purifying tonic prescribed to treat chronic skin conditions and respiratory diseases. Today, modern clinical science has verified exactly what is inside those blossoms. The flowers contain powerful phytoestrogens known as isoflavones, plant-based compounds that closely mirror the chemical structure of human estrogen. Fitting into specific estrogen beta receptor keyholes, isoflavones show potential in protecting bone density and cardiovascular health. But this potency carries a strict caveat. Actively mimicking hormones, they interact with estrogen-sensitive conditions. As this warning state shows, concentrated red clover must be strictly avoided during pregnancy. The plant operates as a sophisticated biological accumulator, synthesizing raw nutrients from the earth into the complex chemical compounds that regulate the mammalian body. We are now seeing a movement known as rematriation. Cutting-edge agronomists and ecologists are deliberately abandoning synthetic agricultural models, choosing instead to reseed red clover directly back into global crop rotations. This hard agronomic science runs parallel to an older bioenergetic perspective. Pioneers of holistic agriculture, like Rudolf Steiner, have long viewed legumes as vital etheric anchors, plants that pull cosmic life force and stability into degraded environments. Whether you observe it through the precise lens of molecular chemistry or the holistic philosophy of energetic resonance, the conclusion is identical. Red clover brings biological order to ecological chaos. So, the next time you see a stray pink blossom pop up in your pristine lawn, you might want to rethink the instinct to reach for a bottle of toxic weed killer. The Earth already possesses the advanced, microscopic technology required to heal its own soil and revive its ecosystems. Our only real responsibility is to step out of the way and let it grow.